Last class we started with data wrangling. Thank you so much, Shubhi. That's so sweet. So we started with data wrangling with R. So we worked on columns, extracting them, changing their data types, renaming, adding a column, deleting a column, rearranging columns and stuff. And then we went on the data part. So subsetting, filtering and sorting and trimming. This is the things we had done yesterday, right? Okay. Of all these things that we have discussed, which tasks did we use dplyr functions for? Extract, not required. Changing data types, not required, but still you can do it using which function? Which function of dplyr you can do? You can change data types? No. Mutate. Mutate can also be used to change data types, but it's fine, not required. You can do the direct method without using a function. Renaming, yes, dplyr function called rename can be used, which is a little bit easier than the base R. Adding a column, yes, we can use dplyr mutate. Deleting a column is very simple process, just assign null, the column will be deleted. Rearranging columns, yes, you have to use the square brackets, just jumble up the column names and just save it. Subsetting can be done using subset function. I asked you to try slice and filter. It's almost equivalent to your subset function. Sorting can be done using order by, passed down to square brackets, or you can use dplyr's arrange function. Trimming is to be used when you're importing your data. Strip.white. Sorry. Trim WS is the function. What is the option that you have to use when strip.white is equals to true? If I do that, then my white spaces will be removed. Or I can use trim WS. Right? All right. Now let's talk about missing values and other parts, what we are left with. Coming to missing values. So in SAS, if I have any blanks or missings, they are represented by a dot if it is a numeric column, or for every non-numeric column it is just a blank. So when you are looking for missing values, you'll be looking for those dots and blanks, right? So in R, any missing value irrespective of the data type of the variable, any missing value can be represented using NA. NA is a keyword, NA is a logical value which represents a missing value. So you have this thing called null, which means nothing. Nothing as in no value, doesn't occupy any space. It neither has any value nor it will occupy any space. That is what is called null. So if I say some object obj1 is equals to null, so one second, just hold on please. I'm on the wrong place, so I'll do one thing. I'll just use a new file. Okay, so if I say obj1 is equals to null, and if I run this, it will create an object, no doubt. If you just look at it over here in the global environment, it's null, no value is present, and it is of 0 bytes. It's not occupying any space as well. Just that the name called obj1 is created. Only the name, nothing else. Now, NA is a value that went missing. a value that went missing, and it occupies some space. So if I say obj2 is equals to na, for instance, you see that obj2 has no value. I mean, na means no value, but it is occupying some space. It is occupying some 48 bytes. Right? So there is a designated place for that, and but it's never available at that time. Like, you have a chair for that particular thing, you have a place to sit, but that thing is never to be found there. Just like the CM of my state. No offense. Again, no offense. Delhi. Again, no offense to the great fans of the great person called, great fans of the great phenomenon called AK. And ask any Delhi guy, they say, no, I didn't vote for him. No, no, I didn't do that. All right. So that's about nulls and NAs. Now, what happens here is, if you are importing data, if there are any missing values, they get imported as NA. Like, if you look at stores, for example, should I open stores here? So there are some values here at acquisition cost per customer where values are missing. So it also happened in your cars data set, right? Your first SAS assignment. Some values went missing. Usually what happens is, in work scenario, you will get data which will be of at least some considerable amount of rows, 10 lakh, 3 lakh, 4 lakh, 5 lakh rows. Some rows may go missing. They might get lost in translation or lost in transmission, or maybe you might have written a wrong code for the ETL process, so some data got lost in between. So in those cases, your task is to have a subset of the entire rows which are missing. You need to subset all those rows. Like, if in this case, in the stores case, I have 3 NA values here, I have to remove these 3 rows here, the row numbers 12, 13 and 14. I have to remove them and send it back to the data team or data management team to ensure that some value goes in there, so they can make necessary corrections. So this is highly mandatory step, because data guys are the ones who are responsible for your data integrity. So they will make sure that there's some value, some or the other value goes in, which is correct, which will represent your correct data. So your task is not just remove NAs, you have to subset data into 2 parts: rows that are complete, rows that contain NA. Now, to do this, your first task would be detecting NAs, of course, right? A small problem here. No, Rohit. A small problem here. Like in SAS, we used to do, like, we used to say column is equals to or equal to dot, for instance. This will check for NA values in that column, ideally speaking or logically speaking. So this will not happen in R. This thing is not going to happen in R directly. So to detect NAs, I have a function is.na. If I use is.na, it will return either true or false. If that particular value is missing value, or if that particular row has missing value, it will respond true or false correspondingly, right? I'll give you an example. Let us go ahead and create a vector of few numbers. And in between them, let's try to insert NAs by force. How many numbers we are done with? So let us insert NAs in between. So this is just like, mimicking your real-time scenarios where you have some NAs in your data. Now if I use this function is.na, gives me trues and false, right? It's true corresponding to every NA, right? It's true whenever it encounters NA. Now let us pass this information into the square bracket notation of V1. Let's see what will happen in that case. So now if I say V1 square brackets is.na V1, so it will return all the NAs, it will return all the true values, right? That's one thing. Now if I say V1 square brackets not is.na V1, what is this doing? So this is returning values by excluding the NAs. So now you have a subset of the vector V, subset of vector V1, which are NAs. And the second one is subset of vector V1 without NAs. Is this thing clear online, guys? Okay. I can have a subvector. I mean, like I can store this in another vector. I can just say v1 underscore clean, for example. So v1 underscore clean will have all the values without NAs inside it. Detect NA subset and remove NA. And a third, if you want to impute NAs, if your idea is to impute NAs with some value, let's say imputing NA with any number or mean of the vector. Yes, it can be done. Now let's start with this. Parisha, I have not come to the rows part yet. I'll come. Don't worry about it. So if I say V1 square brackets is.na V1, right? This is picking up all the NAs. Now if I assign something to it, let's say I'm assigning instead of NAs, let's say I'm assigning them 666, for example, just to identify it easily. So now if I run the statement here at line number 29 and print the contents of V1, so look at it, every value which had NAs has been now replaced with some value. So this is one stage, right? So this one we have already done, like detect and replace. We have done it for vectors. We have seen it while renaming also, right? And this is how it is done. Now let us go back and create V1 again with NAs. So that's imputing NA with any number. Now I want to impute my NAs with mean of that vector. So I can of course do this. V1 is.na V1. So all the NAs replaced with mean of V1, right? Right? So when I run this statement, shut up. So you can see that NAs still remain. See, logically speaking, line number 32 should work, right? It should replace all the NAs with mean of that vector. But it ain't happening, right? It's still NAs here. So problem here is, if I have a vector and I want to do any kind of arithmetic functions, they won't work if there are NAs. That's the thing. So mean of V1 here, mean of V1, it will be NA because of presence of other NAs. Now how to overcome this problem? Every function, every arithmetic function in R comes with an option or argument called na.rm, which you have to set it to true or false. By default it is false. You have to set it to true. So if na.rm is set to true, then NAs are ignored. So if na.rm is set to true, NAs will be ignored. Please pay attention here to line number 39. So instead of writing mean V1, I would rather write that as mean V1 na.rm is equals to true. Now look at the output. Yes, I do have a value for mean. So it is excluding all the NAs, and for the remaining elements it is calculating the average. So every arithmetic function comes with this option na.rm is equals to true. Ignore the NAs if you don't want it.
Does it also ignore the number of
Yes, number of observations will also be ignored. Yes. Let's say I had 5 NAs. Those 5 NAs will be ignored. Rest of the elements out of 18 will be considered for evaluation, for calculating a mean. So now here we go. Line number 32 can be rewritten as this. So mean of V1 na.rm is equals to true. So now look at this, line number 40. This is the correct way of imputing missing values with mean. I have to use the option na.rm is equals to true. So wherever it is encountering NAs, it is replacing it with 52.53. Any questions? Yes, Amit, it will definitely work. What Amit has written here, I am just copying it over here. So mean na.rm is equals to true. This is what it is doing. It is considering the vector without NAs, right? But then this is like almost installing Windows on a MacBook. So use na.rm is equals to true, which is better. My MacBook here. I'm just crying every day. I'll be crying this day. Okay. By default it is false. Yes, Parisha, by default it is false. And Parisha, the answer to your previous question is yes. If the rows have NAs, if I want to omit that, I can delete the entire row, which we'll be discussing now. How to handling NAs in a data frame. Now if I just extend this is.na function to a data frame like stores, you look at the console window, it will be giving me a new data frame of all logical values. So every column, all the columns, all the rows, it will give me true or false value corresponding to each and every cell. It will be checking for each and every cell, and somewhere here it has 3 NAs at acquisition cost per customer, so that's why you have corresponding true values there, right? Now this is not what we want. Of course this is not what we want. Now let's extend this to our previous example. Now looking for NA in the entire table. So that can be done using is.na stores. So you'll get a logical data frame. But again, that's not more sensible. So we have to look for NA with respect to a variable, with respect to a column. Right? So that's what we'll be doing here now. So what we'll do is, instead of looking for the entire table, we have to look for each and every column. So like I say is.na stores dollar location, for example. Now it's a vector, right? Stores dollar location is a vector. It has no missing value, so every value is false, right? Now if I say is.na stores acquisition cost per customer, yes, there are three NAs, so that's why you have corresponding true, right? Now let's take these two lines forward. Let's take this logic forward and apply it to the data frame rows, comma, column, square bracket. So we all know that if I have a data frame, so if there is a data dot frame, I have square brackets for it, which is in the form of rows, comma, columns, right? Now tell me which part is.na has to be applied to check for a column. Rows part only, right? We are to be applying any kind of logical stuff to the data itself. So is.na should be on the rows part. So I'll say stores square brackets. Let us first look with respect to location. So I'll say is.na location, comma. Columns, I'll just leave it blank. I don't want to subset any kind of data. So let's see the output. So I have a data set with 0 rows because no data in stores location is NA. So output to above statement is data frame with 0 rows. Reason, location has no missing values. Clear? What if you do with this acquisition cost per customer? What if we run this thing on that particular variable? So no need to guess, you will have 3 rows which will be output. 3 rows are being output, right? So I'll get a DF with 3 rows where acquisition cost per customer is missing. Right? Clear? Any questions online, guys? So yes, see, this code is not removing, this is just subsetting the main table, right? So it is extracting out all the rows for that particular column which has NAs. So look at this, Parisha. Here there are 3 NAs in acquisition cost per customer, but other variables have some values, right? But still that entire row has been extracted. Entire row number 12, row number 13 and row number 14 entirely has been extracted. This is what I need. So I'll create a subset. I'll call it as substores. Please turn off your mic. I'll call this substores with missing values. So this is one subset of stores. Also I can go for another subset stores without missing. Or subset stores full values, complete values. So I'll say stores not is.na acquisition cost per customer. So I'll have all the rows. So you can see that the 3 rows of acquisition cost per customer which were NA, they were removed, and subset of stores with complete values is 3 observations less than the original one, right? So this data set here, subset of stores with complete values, is the one which I'll be using for my modeling purpose. And this here at line number 57 will go to the data management team for corrections. And when they come back with the corrections, I'll just add them back to my data. Right? Or sometimes you may get a option to impute missing values of a column with mean of that column. So not a big deal for you, right? How do we do it? So stores dollar acquisition cost per customer. Seriously? Yeah. Is.na. stores is dot NA acquisition cost per customer. Again, there is a small mistake here. Look at the previous example. It is V1 square brackets is dot NA V1 replaced with mean of V1 comma NA dot RM is equals to true. So this was the statement, right? Now write the stores equivalent for it, stores acquisition cost equivalent for it. Yes, stores dollar acquisition cost per customer, because this is a vector in which I'll check for NAs and then I'll impute it by mean of that column. Stores acquisition cost per customer, NA.RM is equals to true. Right? So this will impute the missing values. Now imputing missing values with mean is not an allowed way to, is not a legitimate way to get rid of your missing values. But in your case studies and stuff, you will be encountering data which will be a little small. It won't be that huge, right? So you can't afford to lose any kind of data here. So just impute it with mean. But that's not a statistically backed process. So clear with this? So we are done with imputing the missing values. Now you can just try this on to your first SAS case study, first SAS assignment, like detecting missing values and removing them. Just try it. Missing values is done. Find and replace, we have done it on vectors, so I won't be repeating this. The only change that will happen is you have to extract a column as a vector and then find and replace. It's not a big deal, right? We have already done that on vectors. So I'll just do this. Now coming to binning and encoding. Now, till now, the variables or columns that you have seen, whether it is in SAS or in R, if you have seen it. So the data columns will be of two types. It can be numeric and non-numeric. This is what we know till now, right? So numeric data includes numbers as in, let's say, total sales, operating cost, or if I say income or salary, anything, profits. So these things are numeric data, numbers. Numeric data can also be dates, because dates are internally number of days from 1st Jan 1970, right? This is what dates are. Logical values are also numeric. 1 for true and 0 for false. These all are numeric data. What comes under non-numeric data is factors or characters. In other words, any kind of textual data comes under non-numeric, right? So this is what we know till now. Now, this is just a physical division of your data. Physical division as in, I'll get the data type and I'll divide it. This is what something a computer can understand. Some logic behind it and it will do it. Now I'm going to tell you about another classification of your variables, which anyways you will be learning it in with great patience and details in your first BA class, but I'll just give you an introduction to that so that it will be easier for me to tell you about factors and binning and encoding. So usually and statistically, your data is divided into continuous variables and categorical variables. The data is divided into continuous and categorical variables. So if I can explain this in a very easy terms, continuous variables are those variables which have no unique or which don't have any kind of repetitions. Look at things like income, sales, names of people, or in our stores example, we have total sales, we have operating cost, store name. These are continuous. Like if you have a list of students of your college, of your class, no name is unique, right? You can't get any categories of names. Like you can't have a set of names that fall on a set of this thing. No, you can't do that on a name, right? Name is a unique identifier for a person. Yes, there can be a situation where 2 people or 3 people can have same name, but there are some other factors which differentiate them. Of course, they're not the same people, right? They may have similar name, but they're not the same people, right? So name will identify someone uniquely. Or let's say even more better examples like income, sales, and total sales. Those stuff. There can be no link between that can establish unique nature between two. So these kind of variables are known as continuous variables. These things are known as continuous variables. Now, coming to categorical variables, again, frankly speaking, these are those variables which can divide your data. So if I say gender, gender can divide your data into 2 parts. One data which is entirely for males, another data which is entirely for females. Right? Pardon? Okay. I did not see that coming. Oh yeah, they can be third. No offense to anyone. Yes. And yeah, dividing males and females is not to establish any kind of inequality. It's just statistics. No? We're not doing that. Yes. Everyone is equal in this world. Okay. So gender can divide your data, or let's say in our case, I have location, which is dividing my data into 4 types, 4 cities, right? Basically, or I have store type. More obvious variable, I have electronics, apparel, and some other thing. Pardon? No. Yeah, electronics, apparel, and supermarket. Yes. So I have 3 classification for stores. My data can be divided into 3 parts containing n number of rows. So these things are known as categorical variable. They categorize your data, right? Now this is about it. Now what happens in R is R, when it was introduced, it tried its best to identify these variables without any manual intervention. So usually in any language, whether it is R, SAS, SPSS or anything, these variables have to be identified manually. If you are given a set of variables, you should be knowledgeable enough to identify them or classify them as categorical or continuous. There's no thumb rule for it. It's not a thumb rule that every numeric variable is continuous, nor every string or character variable is categorical. Look at this instance, own store. Own store is numeric variable, right? But it's categorical. If I talk about own store, so it can classify my data into 2 types: stores having their own premises or stores having their leased or rented premises. I have 2 sets of data. Online presence, 1 and 0. Stores with presence of e-commerce or stores without any e-commerce website. So it's not necessary that all numeric should be continuous, nor all textual are categorical, right? So this has to be identified manually. So R, what it did is, it tried its best to identify, categorical and continuous, but it failed miserably. Of course it did. So what R does is, by default, it considers all text as categorical. So what worse it can do? Like it has given up. So it says all text is categorical. Baki tum dekh lo. So that's the reason why. When we import a data, by default, the data type of text is factors. Now comes the introduction to factors. So by default, data type of text is factors, but why? Why factors? Why not characters? So here we go. Factors, they represent text, no doubt, but they are built for categorical variables. Factors are actually built for categorical variables. So let us see one example. I'll just take a vector of few alphabets. Let's take this vector saying few categories of shops or categories of stores on Amazon. So I have kitchen, I can have electronics. Stop that humming, please. I can have what else? Apparel.
Fitness.
Amazon.
Fitness.
Okay, fitness. Books. Good. Right? Let's stick to this. So we have these categories. So I'll call this AZ_cat. Amazon categories. Let us create a vector. I'm just creating a vector. I'll call this store categories. Let's call it store categories. I'm just using a sample function. Just randomly selecting some elements from this vector. So this I'm doing just to create a huge vector of categorical variables to demonstrate how character and factor works, to demonstrate the differences between character and factor. So I'll just create somewhere around let's say 50 elements, which replace as true. Of course, replace has to be true. So our store categories of 50 elements, right? And they have these things over here. Now, if I go for unique values of store categories, you see, yes, they're made of these 5 unique values: kitchen, apparel, electronics, books, and fitness. Clear with this? So this here, store categories is a character vector. Now let's convert this into factor and see what changes does it make. So let's manually convert store categories to factor. How can we do it? Which function can convert something to factor? As dot. Something can convert anything to other. So I can say as dot factor stores category. So I'll just save it in another variable. I'll call it store categories underscore f is equals to as dot factor store categories, right? I'll run the statement. Now let us look at the contents of store categories underscore f. There is a slight difference between previous output and this. Yes, no doubt all the 50 elements of my text are here, but there is an additional information here called levels, right? So this is how your factor is representing a categorical variable. If you have levels which you can count, a countable or a finite number of levels, if a factor has finite number of levels, then it's a categorical variable. Obviously, right? Yes or no? If there are considered amount or finite amount of levels, then it is a categorical variable. If factor level exceed or factor levels are almost equal to almost equal, less than or almost equal to the number of rows or data size, it is obviously a continuous variable. Like I have given the example of names. So if I have 50 names, let's say 2 or 3 or 5 people max to max have same name. What about the others? No, there's no possibility, right? Yes or no?
Yes.
So I'll have 45 levels. It's almost equivalent to the data size, right? So that variable is continuous, right? So this is how R will help you to identify a categorical continuous variable without you having to spend any kind of these languages are meant to function with the least human intervention as possible. So you can just put up a logic, write a logic, and you can clearly clear out or detect categorical and continuous variable from your data. Easy, right? So this is how factors are helpful. Let's see some more functions which loom around factors. So I have a function called levels. Needless to say, levels of stored categories underscore f will give me a character vector of all the unique values in that particular factor. Now, yeah.
So, while we are getting this information, which all are categorical and this, does it helps like what's the mean?
Wait for your BA class. That's where it makes more sense, right?
Yeah.
So based on the variable type, whether it is categorical or continuous, your exploratory statistics will depend on that. So if you are using any textual variable which is categorical, text and categorical, you have to use certain metrics. If you have numerical variable which is categorical, you have to convert it into some other form and use certain statistics to that. You can't find mean median mode for online presence or own store, right? You can't do that, isn't it? So you have to separate them out first. Like I said, it's not necessary that all numbers are continuous, and it's not necessary that all text is categorical. So you have to do the necessary changes.
So it's basically to
Identify and then do yes. So your graphs, your visualizations, everything depend on this, which we'll be anyway seeing in total luxury and when we come to BA first class, right? We don't have time machines. Any other questions, classroom or online people? Hello? Hello? Online people? Good.
One question.
Yes, please.
If in this levels function I put a character variable, for example name, which has some repetitions, let's say 4 or 5. So it
will give you a warning. If some levels are added, no data is present in that level. Same happens with the original factor vector. So let's say if I have stores category underscore f, you're adding a new value to it, which is quite different from these categories or levels. Let's do this. So if I say to stores category f using C function, so all the elements plus I'll add one more. Tell me one more apart from this. Apparel, books, electronics, fitness, kitchen. Huh? Okay, you married? Okay. Planning for your future. So you see, okay, this doesn't work this way, but if you do this, your data gets misplaced, right? Your data is gone. So it's too bad of R that it is not showing any warning, but still, you should realize that your data is gone. You can't do that, right? So yes, there are other ways to handle this. no doubt. Other ways to add something to your existing factor vector, which we'll discuss eventually. But yes, you have to be very cautious enough when you are working with factors. So these are not like your regular characters. These are not your regular strings, but they are something which represent your categorical variables, right? Okay. That's about levels. The reason why all these things are happening is because of these strange characteristics about factors. Believe it or not, factors are internally stored as numbers. Factors are internally stored as numbers.
Like 1, 2, 3, 4, they have clear numbers.
Yes. It's just like the okay. No, I won't. Okay, it's just like your innovative Apple using Intel processor inside, which is anyways available on your PC, plus you don't have to pay much amount for that. So factors are numbers internally, surprisingly. So let's see how it is happening. If I happen to convert store categories, which is a character vector, to numbers, this is not possible, right? The values will go missing. But what if I do this to factor, right? One second. Oh, okay. So let me create this again, please. Stores categories _F. Okay. So if I convert this into numbers, you can see you have numbers, whereas stores _category F is supposed to be text. Can anyone explain me why this happened here? The highlighted text. Why stores _category F is numbers, despite the fact that it is representing text. Anyone from the online people can explain this, why it is happening?
The indexing, levels are indexed.
Levels are indexed. How?
Accordingly, like we have
Showing the index of levels. So if you look at Apple, if you look at the what?
alphabetical order.
So sorry. So look at this. So these are first arranged in alphabetical order, and everything has a number. Apparel is 1, books is 2, electronics is 3, fitness 4, kitchen 5, and everywhere it encounters books, let's say. So books here 1, again here 13 in 14th row 2. So everywhere it encounters books, you have 2 instead, right? So this is how factors are stored internally. Your levels are arranged alphabetically first. Every level which is thus arranged is given an index. Internally, the text goes as an index. Clear with this? Why does that happen? What's the use of that? Why does it happen? Why does factor take it that way? So this process here is called encoding. The process by which each and every levels are assigned some number, and instead of the text we have numbers. That process is called encoding.
Is it because it takes less space?
Not because of spaces, but I don't know why. Like it's much easier to reference. It's much easier to find out any kind of descriptive statistics. Right? So for all your statistics needs, you need factors in your data. But for rest of the tasks, if you're going for any kind of modeling or any kind of text analysis, natural language processing, machine learning, those scenarios you have to avoid factors, because none of your string manipulation functions would work on factors. Any string manipulation functions that you see, they're not applicable on factors. Now let us look at few more examples. So I have a function called factor. I have a function called factor which will take in some character vector inside it, and it has also let's say I'm just passing out few variables here, a few characters like A, B, or C or something randomly. I have another option called levels, in which I can specify what are the levels of that factors, unique elements, or I can also use this function called labels. Now this is your task. Here comes your task. I have three different cases. I mean, like, I can't use this in all cases. There are three different cases where you have to use X, levels, and labels. So now it's your chance to figure out which is meant for what. Bluntly speaking, factor function will take X or a character array as input and gives a factor. It gives an equivalent factor array as an output. So if it's almost equivalent to as dot factor. It's almost equivalent to as dot factor. So one thing I have solved for you. Now you have to figure out what is levels and labels stand for. If you are not able to do that, I will just explain that to you on Saturday's class. Don't worry about it. And also I've given you one more task yesterday, to figure out how slice and this thing filter works, right? I hope nobody would have done it. Yesterday was Saturday, so I can understand. So you have the week coming up. Next Saturday we can see those questions. Very good. You can come here. Come on. So Shubhi asks, is there any option during data import so that characters are not imported as factors? So this will be our closing topic for factors. How do you handle it while importing? So just let's get back to basics. So I have stores, data set in stores. I say read.csv or read.table or anything. So let's do for read.table. So in read.table, I'll say file is equals to my documents, data sets, stores.csv, and in it, header is equals to true, separator is equals to a comma. Now I have an option here called strings as factors, which I will have to set it to false. So if I set strings as factors is equals to false, then by default factors will not be imported. So if strings as factors is set to false, then text info is imported as which type? Character type, not the default factor type. So that's about factors. That's the first around factors actually. There's nothing much to discuss beyond this. Now let's come to binning and encoding. So if I have a continuous variable, if I consider a continuous variable, like let's say age, for instance, age is continuous variable, right? Now, according to age, I will just create some ranges like age. Let's say I have data on insurance. Let's say my age can be less than 18. That's one category. My age can be 18 to 25. Let's say most of the young population. I have 25 to 30. Peace be upon these people, because it's the most crucial phase of anybody's life. 30 to let's say 40, where they get acquainted to all the miseries. 40 to 50, they start thinking about hospital stuff and all. And 60 beyond, like if you had lived this life well, the 60 beyond would be good.
And 50 to 60, there is no life.
Yes, that's a good thing. I totally forgot about it. 50 to 60, okay. So it's again the repetition of 25 to 30, basically. So I have these categories of people, so I'll just label them. If it is less than 18, it's a child, it's young. I'll call this a little bit more young. What do you call it? Mature. No, that's a different word. Like 25, 30, let's say, what do you call this?
Curious.
is male and 20 to 30 is
So how do you categorize 25 to 30? Which word should we use? Like, I can't use young. Okay, let's do one thing. 18 to 30, let's use the word young. Give some satisfaction. Yeah. 30 to 40, let's call it mid-age. This is 40 to 50 is okay, kind of old. Waiting. So greater than 60 is senior citizens, let's say. So can't you categorize your data like this, right? Like pick up the number variable, go for conditions and categorize it. Now what we'll do is we'll take our stores data set. For again a serious example, stores data set. I'll take total sales. Total sales column, I'll take it, right? So my total sales is ranging from 71 to 200, somewhere around. So which I can see it over here. If I look at my data and just sort my total sales, it is 71.1 to somewhere around 472. So based on this, I'll just create my categories. So I'll create for first category, which is things which is less than 80. If your total sales is less than 80,000 or something, I'll call it as low performance store. If it is 80 to, let's say, 300, no, it's huge. 80 to 200, average performing store. Performing store, that's an appropriate word. And I have 200 to, let's say, 300. It's a good performing store. Chal raha hai, kaam chal raha hai. And anything beyond 300 is awesome. I could call it like high performance store. Right? Let's categorize that. To understand this categorization, like how do I do it and all that stuff, what we'll do is we'll see some example. We'll see some food example. Just wish to add a column called food to the table. So I'll call it as stores $food. Now I can add variables directly using the dollar sign, right? So if I just assign something to this, like I have a lot of things to say, but like without offending anyone again, say rice, right? Doesn't offend anyone, right? Okay, everyone has it. So if I do this thing, I'll add a column called a food in the end, and every row will have rice. Let's do something different. Let's apply some logic here. I have location, right? I have 4 cities. So let's see what is famous in each city. So if I have Chennai, Delhi, Kolkata and Mumbai, see what's famous food in each location. Anyone from Tamil Nadu? Anyone here from Tamil Nadu? Yaar Tamil illa yappa. There has to be one person from Tamil Nadu. I know that. Okay. In Tamil Nadu, what's famous there is sambar, or you have pongal over there. It's a very good dish over there. No, it's a name of a dish. Pongal is the name of a dish. Delhi, guys, what's famous in your city? What's famous in Delhi? Previous batches, most of them they used to say that chaat is famous here. Ha, chola bhatura, yes. Chole bhatura. I can't spell it. I'll just put it as CB, for example. Can I assume what that is? Bengalish. What's famous in Kolkata? Sweet. Not Majbhat. Majbhat is not that. Like Rasgulla. Rasgulla is actually from Orissa. Sandesh, yes. So not everything is all over there, right? It's Sandesh. It's fine. It's okay to pronounce it like that. If anyone says vada pav, they are dead. The vada pav is not the only thing available in Mumbai. Come on. Seriously. Puchka is, Golgappa. It's an universal dish. Bhel puri, pan puri. No, not those stuff, man. Mumbai is not just vada pav, man. Seriously, but still, I'll add it. Just to save some time. Alright. So what I'll do is, to the food column, I'll add these dishes based on some condition. I'll check if location is so and so. I'll add that particular food over there. So let me first delete the column that I have created. Now let's do this. I'll say store $food. Please pay attention to this. I'll add Pongal if and only if it is Chennai. So to do this, I can actually go for a square bracket indexing right at this stage to the food. So please look at the place where I have put the square brackets. Here I can directly type on the condition. So it's stores $location equal to Chennai. Then it's Pongal. Let me run this statement and see what happens in stores. Yes, one column has been added, and wherever there is Chennai, it has put Pongal over there, right? Yes, these rows have Chennai over there. Here we go. Right? So you can just make it 4 times, and you can keep on putting those places for each and everything. Delhi. And Mumbai. What? I think it's getting jealous because food items and stuff. So I was getting hungry. Now running all the statements again, you have a column called food, which corresponds to each and every location, right? Now, online guys, it's your turn now. Coming back to the question, I'll have to look for stores total sales, and based on this total sales, I have to create a new variable called store performance category based on the condition stated above. Let's call it store performance or store category, just to have a simple name. Now I want online guys to write a code, all the 4 lines over here, and assign it appropriately. Please do it, and so does the classroom guys. You can write it in notebooks. How do I do it? Based on the previous food example that I have given you. It can be done, isn't it? It can of course be done. Online guys, come on. I'm just waiting for your answer.
So total sales is less
The one who posts first here will get nothing. Yeah, the one who posts here first will get a free tips on R Shiny if they're interested. Of course, download it from the internet. I'll save you the time for downloading whatever you have. You want packages? I told you on the first day, right? If you need packages from this, get a pen drive, just copy it from my system.
No, you told that you need to buttering.
You have to give some rishwat or something. Then I'll be giving you that. Donuts can do, or But no, if you need those packages, I do have a lot of them. You can just copy it in a pen drive and take it. Come on, we don't have luxury of time, online guys. I've been a little bit slow for the last 2 days. But very much active to answer the questions, which food is famous and which place. Very good, Mohit. First person to reply, first statement. So you guys agree with this? Yes? So complete the other 4 online guys. Yeah. What? Harshad, you have written this wrong, my friend. Harshad, please correct your code. It's not the way you're supposed to write. I don't know what you are trying to do there. Harshit, did you understand what is the error that you have done over there? Please correct it. For a while even I went blank. What happened? Stores total is greater than 80. Stores total sales less than 200. So it's an average performing store. Excellent, Mohit. Sorry, Manoj. Go on. Do for the next 2 lines. So greater than is equals to 200 and less than 300. So it's good performing store. And if it's anything greater than 300, it's the best high performing store. Right? So this is what this function, this is what is all about binning. So if I run all these 4 lines here, creates a column called stores category with corresponding values there. Any questions online guys, please let me know. Is equals to 300 saying.
You can directly replace these values.
Directly replace?
In the same row, not creating a new variable.
No, you can't do that. Original data will be lost, yes. Original data will be lost. But that's not the motive of binning, right? Binning is creating a new variable which contains those categories.
Can we do that? I'm just asking, can we do that?
Yes, we can do that. Instead of writing it as stores category, just write it as stores total sales. Then it will replace the original values. That's not a good thing to do, right?
And so one more thing, can we, like here we are writing the 4 steps
Uh-huh.
for rich and low performing, high performing and all.
Uh-huh.
So can we do it in a single line?
Single line?
Yeah, single statement.
Why is everyone is a fan of doing things in single line? No, you can't do that, sir.
No, we can assign that that where we are putting in store total sales is greater than or less than 80, and store total sales is if store total sales is greater than statement.
Did I teach? Did I use if? Did I teach if? No, right? So.
No, just asking that can we use that or
no?
Okay.
Why is everyone a fan of doing things in single line? No, not everything is in single line. Everything has stages. The Sanat R is not SAS. No, select case, nothing. So my target here is, because I'm consuming my RAM, I have to ensure that my cycles are less. So no such stupid functions like case when, case, or if. If is there, but it's avoided. That's to be avoided. If we'll cover it in a while. We'll be covering if in a while. How cycles are calculated. So CPU cycles are actually a function of your algorithmic what do you say, complexity. They measure it using log n, O log n, and those stuff. So because this is not a computer science class, we'll not go into that, Amit. We can discuss it sometime later. Like you can come to analytics labs for a tea. We can do that. And by the way, even if I have to compare between dplyr function and the square brackets, no doubt dplyr functions are more convenient for an user, but square brackets are much faster when it comes to data handling. So please use it with caution. Like if you are having large data sets, make a good practice of using square brackets. Things will be much faster. I mean, now stores is just 32 rows, which is nothing. Like you have to deal with data which goes up to a million rows, a billion rows actually. So that's when the problem comes. Okay, that's about binning. Encoding is the reverse process of binning, which has to be done in the same way like we are doing this. So let's say we are taking this thing called online presence over here, ones and zeros. So if I have 1, I'll create a new variable and I'll call it online store. If it is 0, I'll call it as no online store. So that's quite simple. I'll call it as stores dollar, let's say online presence status. So if stores dollar online presence equal to 1, then online store is present. Wait. So if it is equal to 0, then it is no online presence. That's it. This process here is binning. Now I'm converting a numerical variable into a text variable. That is encoding. Encoding. So encoding here, remember I'm not using the word categorical and continuous. Encoding is simply converting a numerical variable to text. One second. What?
as we do in a SAS, like value labeling.
Value labeling, you can call it, yes, like add value label in SAS. Encoding can also involve the process of creating a dummy variable. Encoding can also mean a process of creating a dummy variable. Now that means, let's say if you have categorical variables like location, so you assign 1 to Chennai or 2 to Delhi and so on. This process is known as process of creating dummy variable. This is also known as encoding. This is also called as encoding, right? The reverse process of binning. Binning, however, by definition is converting a continuous variable to categorical variable, right? Any questions so far on binning and encoding? Now, well, in the end, let's see duplicates and take 5 to 7 minutes. We'll take a break afterwards, right? So let's see duplicates, removing duplicate values. Like NAs, duplicate values are also not so meaningful in my data. I need to get rid of it. Not simply by deleting, but by creating subsets of duplicated values and just passing it on to the data management team so that they can give me the corrected data, right? So again, to remove duplicates, you have to first detect duplicates, of course. So I have a function called duplicated. I have a function here, duplicated. Let's work upon this vector here. We had a vector called store categories that we had created. Like we had created using a sample function, right? One vector we have done. So let's use duplicated function for that and see what is the result. So duplicated store categories. That's giving me trues and falses. Can anyone interpret this output? Why duplicated function is not you? Is giving trues and false.
Just for the first time the value appears, that's the false.
Yes.
Everything is
yes.
It's duplicate.
Yes. So the working around duplicates is that yes. So if books is happening for the first time, it is false. The first occurrence is always false. Apparel, first time, so it's false. Electronics, first time, so it's false. Look at the fourth element here. It's again electronics, fourth and fifth. That's why I have fourth and fifth true. Apparel, electronics, both are true again. But come fitness here, fitness is false because it's the first occurrence. First occurrence, not the lowest, first occurrence. So duplicated will give you true and false. If it is the first occurrence of an element, it's false, else it's true, right? Now if I have trues and falses, let's take it forward to the square brackets, right? Now look at this. Store categories. Okay, now before we go there, what if I use exclamation mark here to duplicated categories? So duplicated function will return false for the first occurrence. Right? Not duplicated will return true for the first occurrence. And subsequent occurrences are false, right? This is what it is doing. Now let's take this forward. Let's take this not duplicated ones to the square bracket. So I'll say store categories, square brackets, not duplicated store categories, not duplicated. You're not answering. So what do you get? I said you're not answering. See, he has done a PhD in R, so you can expect answers from him. So I don't want him to answer. So line number 180 will give you all the unique elements from that vector, right? That's what is not duplicated meant for. Now if I use the same thing for duplicated, it will give me all the repeat values. It will simply ignore the first occurrences and it will give all the values which are being repeated, right? I have two distinct categories, right? One which is containing values which are repeats, one which contains values which are not repeats. That's it, right? So this is the logic behind duplicated function. Any questions on this? Anyone? Now let's quickly take this forward to a data frame. What I'll do is, because stores dataset has no repeated values, so I'll take another dataset which I have. I have something called score. Sorry. So I have scores.csv. If you look at this data here, scores, none of the row from 1 to 7, right? They're unique, and from 8 through 14 we have repeated. So this is repeats. The first ones are unique, right? My task is to get rid of these. Sorry, these 8 to 14. My task is to get rid of those records. Let's see how it is done. So the same duplicated function, let us take it forward to the dataset called score. So if I say score square brackets duplicated score. So because I'll be looking for rows, so I'll put this in the rows part. This entire thing is data part. So look at it now, the output here on my console, it gives me rows which were repeat. And the same thing, not duplicated score, would go for the unique rows. Here is going for the unique rows. Clear with this? This is how you get rid of your duplicates. Simple as that. Simple and straightforward. There is no functions, there is nothing involved in this. Faster and efficient way of getting rid of your duplicates. Now this is getting rid of duplicates on an overall level. This is on a table level. Now how to do that on a column level? So let's say you are asked to remove, sometimes it may happen, if I have a student data set, for example, I have roll numbers, which is supposed to be unique. If they're using any software, if they're using any DBMS software, while creating the table itself, you have a clause called no repeats, right? Unique clause is present so that the data will not get repeated. Let's say by mistake, in my student's data, I have some repeats in the roll number column, which is not acceptable, right? Repeats in the roll number column is not acceptable. So how do we handle that? So in that case, we have to look for duplicates in roll number column, remove those columns and just create a subset out of it, right? So let's say on a column level, in this case, for example, extract duplicates based on students on score $student. So that's very simple. So if I say score duplicated score, dollar, student. That's all I have to add. And this will remove duplicates on column level. It will look out for that particular column and it will remove the duplicate. Please remember one thing. If I take this data set called score, I have 14 rows here. A row is identified as unique. A row is identified as unique if all the values are unique. So row number 1 and row number 8, please look at it. So 8 is being treated as duplicate because each and every value in that row is being repeated. Capillarity 1, 94, 91, 87. Each and everything is getting repeated. So that's why it is considered as a duplicate. Or else it wouldn't have been. Right? If any of the value were to be different, if 91 were to be 65, then that row would have been considered as unique row. Right? So for a row to be unique or duplicate, I have to look for each and every element. Each and every element is looked for. And that's a disadvantage when it comes to looking for more refined way of treating your data. The second example that I have told you, if I have student data and I have repeats in roll numbers, right? That's when I have to look for column wise, right? That's more sensible. So this is how you will be doing it. So in duplicated function, you have to just pass on the column name. Any questions in this online guys or classroom people? Any questions?
So, but here you have written that score, big bracket, duplicated, and comma. That before the comma, it shows that it will detect the rows, right?
So it will go for the rows based on that particular column. Okay. It's almost equal to your sort, for example. Sort or ordering also you'll be doing on a column, but the things are written on the row part because we are looking into the data. If you look at it logically. If I run this, the answer will be quite similar to what we had before because every row is a repeat. You can test by changing the data contents. One small example we can do, we can use fix quickly. So let's say for capillarity 91, I'm changing it to 65. Clear? Now the data has been changed. Please note the fact that I have changed the data. So which means according to my logic, row number 1 to 8 are unique rows. Yes? Let's confirm that. If I say scores duplicated score, not duplicated score, you see first 8 elements are being included because this row is being treated as unique, row number 8, just because of this number 65 here. Let's run this on score student. Look at student for example now. If I look at this column here, student, till 7, Capillarity, Dubose, until McBain, everything is unique. Afterwards, there are repeats, right? So if I have to remove repeats based on that, now look at it. So based on student column, 8 to 14 are considered as duplicates, right? Yes or no? Because this is looking column wise. Now did you understand the difference, online guys and classroom people? Okay. So this is also done with one small problem here. Merging is like, combining two tables based on a common column, right? That's merging. And I don't have to explain the different kind of joins. I've already done it in SAS, right? Now, unlike SAS, you don't have to sort your data before you wish to merge. All you have to do is just get those columns which are common and try to merge. What I'll do is, for this purpose, I'll just import two data. One is demographic data, which I have it in my datasets folder. So I'll be taking two datasets, one which contains details of the customers and another which contains transactions. So I'll have a common column between them. I call transaction data. right? So transaction summary.csv. So I have two data sets. This is my transaction data, but before that I have something called demographic data. I think I didn't import that. Okay. So yes. So these customers have done some transactions and I have that data over here, transaction. So if you look at customer name of transactions and cust name of demographic. So I have a column which is common, right? So I can join based on those two. Now let's look at how joins work in R. I have a function called merge. Merge can be used to join two tables. Straightforward. Now here we go. So I will begin with two tables, left and right tables, when I start going for joining. So right I will call it as A, left I will call it as X, right I will call it as Y. If I want a full join, I'll take common elements. Yes, of course, I look for common matches from that column, but I will take all the rows of X and all the rows of Y. That is my full join. Every row of X and every row of Y will be taken and it will be joined. That is full join. Right? Right. Inner join means only the matches, only the common rows. Left, all of X and none of Y. Right is none of left and all of Y. Any questions in this? Right? I mean, like the same definition of merge that you know, I have just changed the perspective. That's it. A small change in the perspective. Right? Any questions online, guys? Okay. Now, let's look at the function here, merge. Merge function takes two values first, X and Y table, left and right table. That's my first two arguments. My second argument can be either by or by.x and by.y. It depends. So here in this case, if both transaction and demographic, both the tables, the common element, the common column in both the tables have the same name. Let's say if it is cust ID in both the tables, then I'll use by argument. In this case, it is different, right? Transaction data has customer name and demographic data has cust name. In these cases, I have to say by.x and by.y. It means that in X table, it is customer ID or customer name. In another table, it is cust ID. This is what I mean by by.x and by.y. Now, this is the basic inputs to merge function. Coming next is all.x and all.y. By default, all is set to false, which means we are going for inner join. All, if it is set to true, it becomes full join, all of X and all of Y. All.x is equals to true, then it becomes left join. All.y is equals to true is right join. That's it. This is how your merge function works. I'll write the syntax for it. Please have a look at it. So if I want an inner join, then it's merge. The first argument, let's say I'll take transaction data as my base table. Transaction data, demographic data, that's X and Y. By.x in transaction data, it is customer name, which is the common column. So within quotations, I'll write customer name. And this is the place, like if you are willing to match with multiple columns, you can do it. Just you have to use the combine function for it. Use combine function and pass on multiple values, multiple column names if you require to merge in multiple columns. But here in this case, it is only one column, so I'll just remove the use of C function. So X is equals to customer name, by dot Y is equals to cust name. This is how it is in Y table. But this is just an inner join. If I run the statement, so you get 7 observations of 11 variables. 7 observations which are common. 11 variables are variables from both the tables. That's inner join. Straightforward inner join. Any questions in this, online people? Now look at outer join. So what is the only thing that can go in outer join? The all argument. If I said all is equals to true, which means both X and both Y table, all the elements will be printed, whether or not it is common or not. So if I run the statement, look at outer join now, it will have more observation than your inner join. Number of variables remain same, but observations have changed. They have of course changed. And look at it. So Rajesh and Ramu, they are not present in the demographic data table. The right table, they're not present. So you have NAs corresponding to them. They're not common column, they're not common elements in both the tables, they're not present in both the tables, they're present only in transaction table, and they're not present in demographic data table, hence I have NAs. Same goes with last two people here, last three, Michael, Pratik and Raj. They are present in my right table, in demographic table, but they have no transactions done, so it is NAs over there. Quid pro quo, this is a outer join. This means that it is an outer join. It is including everything, right? So it's an outer join. Any questions now? No, right? And needless to explain the left and right joins. So if I have to go for a left join, it is all dot X is equals to true. That's correct. All dot X is equals to true. That's left join. 9 observations of 11 variables. So comparing left and outer join, left join is not including Michael, Pratik and Raj, which belong to the right table. Michael, Pratik and Raj, they belong to my right table, so they're dropped, and that's how I have my left join. And I have Rajesh and Ramu from my left table, whose data is not present in my demographic data table, but they are just included, right? This is left join. Opposite of left is right join. Called RT join or right join. It's all dot Y is equals to true. That's my right join. So now Michael, Pratik and Raj are included, and these two rows, Rajesh and Ramu, are not included. An outer join is actually a combination of left and right join, right? Any further questions? Anyone? Classroom and online people? Yesterday we have seen SQL statements, like if you are acquainted enough in writing SQL queries on joins, like select this from, select A dot column and B dot column from table 1 as A and table 2 as B. That logic can be written and it can be executed by SQLDF statement. So people who are acquainted with SQL, I request you to try joins, the SQL style joins, and do it. For rest of us, we have dplyr. We have dplyr, which also implements SQL type joins. So you have left underscore join, right underscore join, full underscore join, inner underscore join. What else we have? Semi join, anti join. Anti join is Semi-join is actually set subtraction, right? Anti-join is set subtraction, something like that. You know better than me. I don't know. We have done that in SAS, right? Semi and anti. No? Okay. Okay. Strange. Can anyone explain me what is a semi-join? Half join. Eh? What's a semi-join? Let's try it out. Let's pass the inputs. Now, I think when I'm doing this, this should be an example for you how to use these functions from dplyr. Please pay attention. So same thing, what I've done for merge, X table, transaction data, Y table is demographic data. Now, here, this is a little bit tricky here, the by argument. There is no by.x and by.y. So all you have to do is you have to use a C function. That's mandatory. Within quotes, you have to specify the column name in my left table. So in my left table, it is customer name. So within quotes, I'll be specifying customer name, which is fine. If both the tables had the same name called customer name, I would have left it like this. But it is not the case, right? I have customer name in my X table and cust name in my Y table. So I have to do something like this. By is equals to combine function customer name is equals to cust name. This is what I have to do to make a match, right? Now this syntax holds true for each and every statement that I have written up there. So I can copy this in left join. Oh, one second. Okay. See, there is no benefit of dplyr. 1 second. Left underscore join, or I'll call it left join underscore D for dplyr. So this is left join from dplyr and this is left join from the merge function. Both are one and the same, right? So the same syntax for each and every function out there. Full, inner, semi, anti. Now look at the output of semi join. Seven observations of 5 variables. So semi and anti is all about the number of variables. So in all these cases, left, inner, outer, and this, there was no reduction of variables. See, look at this. If I go for inner join, there are 7 observations of 11 variables. So 11 variables coming from both the tables. Semi join, on the other hand, it contains elements which are common in both the tables, but it will print from only one table. So it is printing from my left table by default, right? That is semi join. And then what is left join in that case? Left join will print both the columns which are common and which are not common, and all the columns. It will print rows which are common and not common, and all the columns it will print. But semi join will take the left table and will print only the common elements. There is a reduction of variables in semi join. That one must have to note it, right? And what is anti join now? So just copy this over here. Anti join underscore D. Anti-join is quite opposite of your semi-join. The rows which were not included in semi-join comes in anti-join. Only from the base table, yes. Only from the base table. Any questions? C function is not mandatory in that case, Ayush. You can just ignore C function, but this is just for better understanding. I have written C function over there. A semi-join returns rows from the first input if there is at least one matching row, and anti-join returns row from the first input if there are no matching rows. Thank you, Manoj, for that. Source. Oh, I thought you typed it. But thank you for being honest. And that doesn't qualify you for your photograph to be published on the currency notes. But still, thank you for your honesty. Okay, that's about merging. Oh, okay. So we are left with binding and group by. Binding is nothing but appending. Binding is almost like appending. So I'll not show an example of this. I also wanted to try this, right? Because this is pretty much self-explanatory. If you can get any data from your SAS data sets, you can try out the statements. Now, look at the logic here. If there are two tables, I can do any kind of binding, right? So, case 1, the same number of rows. Both the tables have same number of rows. Table 1 has 5 rows, table 2 has 5 rows. But different columns or maybe same column, different columns, let's say. What kind of binding can be done? How can I paste those two tables? Let's say same number of rows and one has 3 columns, other has 2. How do I paste both of them? I can paste both of them, right? I can just paste both of them, append both of them, right? How can I? I can append by columns, right? So three columns, 5 rows, 2 columns, 5 rows. Just paste them together. Just join them together. Now, if I can just show that to you on Excel. So that be 3 columns. 1, 2, 3, 4, 5. 5 rows. Right, including the header row. I'll just put it in some color. And I have another table which has same 2 columns, 5 rows. So all borders, and the first one is colored. So I can just bring these two together, right? Just paste them, right? I can do that. This process is called column bind, right? So I can perform column binding. Right? Column bind can be performed, and the function to do that is cbind. Cbind stands for column bind, and two tables having same number of rows can be combined. Now what is the output? Resultant will have 5. I mean 3 plus 2, 5 columns, and rows are anyways not changing, right? Okay. Case 2, same number of columns and different rows. Let's say one has 5 rows, the other has 2. The same number of columns. Let's say table 1 has 3 columns, but it has 5 rows. The same one which we had taken before. And the other one has 2. So 3 columns, same number of columns, that is 3 columns and 2 rows. So I'll do this. this is a row bind. So I have two tables like this. I can perform a row bind. How it is done? So in R bind, if I do this for these two tables A and B, so I can just cut this and paste it below this table, right? The column names gets overwritten. This will get overwritten, and the column names will get overwritten, but the resultant tables will have 5 plus 2, 7 rows, but same number of columns as in the base table. The column names in the base table will never going to be changed. And that's a row bind, R bind. So that's about binding here. Uh-oh. Alright, any questions? Online people, any questions? This is different from merge. See, this is what is called appending. Binding is what is called appending. And Sahil, I see every difference between appending and merging, right? So what's the difference? Merging is done with some logic like common rows, common columns, and that stuff. This is plain binding. This is just plain simply pasting it. Yeah. Did you get it, Sahil? So C bind is column bind, R bind is row bind, bind by columns, bind by rows, and you know the conditions where we have to use row and column binds. What is the prerequisites for that? All right. Last but not the least, group by statements, and here we go. How do you group by in SAS? By using which one? Not proxyquel. By clause. Okay. All right. Your SAS skills needs to be brushed up for common good. Yeah. All right. So grouping in R is not as painful in SAS, to be honest. Like, see, I off the record, not the base package. So the reason why we will be using dplyr instead of base in R is base grouping is little bit hectic actually. Like again, you are increasing the complexity of understanding the code, right? So that's why we are not using any base functions for this. Yes, there are functions available. You may use it. There are aggregate functions available, but I don't find that they are much useful. So let's make use of dplyr. So I'll quickly load dplyr. Let's say in stores, I wish to find sum of total sales by location. Easy peasy, right? So if I have to write an SQL statement for this, that would be select location, comma, sum total sales as sum of total sales from stores group by location. So this is the SQL equivalent of it. Let's do that in dplyr. It all begins with a group by statement. Group underscore by. Group underscore by. I'll just create a temporary table. I'll say T is equals to group by which table we are grouping? Stores. Based on which variable? Fantastic. I hope you understood the syntax of group by function. In this example, I'm grouping by location, so this should be my group by statement. Group by stores location. Right? Any questions so far? No. Proceed. So I have created a temporary table called T over here. Okay. So moving on. For results table. The result table will contain the exact result of what we are looking for, right? Now, every group by statement of dplyr should be followed by a summarize statement. Every dplyr group by statement is to be followed by a summarize or a mutate statement, anything, but in this case, because we are calculating some values, we should go for summarize statement. So result table is equals to summarize. Now in summarize, the input to summarize function is the group table, that is T, which is my temporary table. So summarize T, comma, you're trying to calculate sum of total sales, right? So that's what I'll write it over here. Sum of total sales is equals to sum total sales. NA dot RM is equals to true. Any questions on line number 244? Is there anything that you did not understand? Please let me know, especially the online guys. If you have any questions on this line, please let me know. Amit, T is a temporary table that I have created in line number 243. Please pay attention on that. Any other questions? Right? Clear? We can move on, right? So executing the two statements there, I get result table, 4 observations, right? Total, the sum of sales from each and every table. We have it, right? So if you can just visualize it in Excel per se. So let's insert pivot, and that be location wise sum of total sales. This is the table that we have got in R, right? This table what we have got over there, right? Any questions? No, right? Let's just do another example. Yeah. If he's not stopping, he is getting killed, and his death will be slow and painful. That noise is irritatingly funny, right? What is the code in base SAS for the same? This is R class, this is not SAS class. I won't be saying it. No, I will not open up SAS now. Okay. NA.RM, Sridevi, it's an option for each and every arithmetic function which will ignore NA values. Okay, base R equivalent of this, just for your information sake I'm telling this. Don't try to learn this. You will forget the very meaning of your existence in this world. Don't try to learn the base R grouping. But it's somewhat like this. I'll use aggregate function in which my data is stores and by location function is equals to sum, for instance. No, it won't work like this. No. Okay, 1 second. So location Nope, nope. Even I forgot how to do that. Let's just leave it. It's not required for us now. All right. Let's stick to dplyr, the easiest ones. Okay, let's do one more example. That was sum of total sales by location. Let's say sum of total sales by location and store type, for example. So you're going to tell me group by? Yes. C? Why do you need C? So stores, location, store type. Please look at the syntax of group by now. You don't need a combine function. Yes, it's a very good thought of yours that you have to pass on combine, but it's not required for group by. This is the syntax. No, you don't have to use it. We can't use it actually. It's a syntax error. Now you have to just pass it on directly. So this is function overloading. You can keep on passing number of arguments.
Group by, and then you have to write the file name, then column name.
Column name or names in which you want the grouping.
Column name 1, 2, 3.
Yes. So I hope now you got the syntax of group by, right? So this is group by stores, location, store type, and then finally result table is sum of sales, sum of total sales, n.rm is equals to true. That's it. Now here is a little bit catch. Please learn this syntax as well. The use of pipe operator. Pipe operator. Pipe is somewhat like this: percent greater than symbol percent. So please look at the lines that I'm going to write, which will be equivalent to the lines written in line number 248 and 249. One second, I'm not done yet. Look at it. I'll begin with stores. Pipe operator is just, it's pipelining things. Pipelining as in putting it in an order, which goes one by one in that given order. So I'll begin with stores. I'll put a pipe operator here. Immediately I'm going for group by. And please notice the change in the syntax of group by statements. I'm not mentioning the table name here in group by. I'm simply writing location and store type in which I need the grouping information. Again, pipelining to summarize function. I'll just write it in the next line. And also look at the way how to the summarize function I'm not passing any table input, because the pipelining goes like this. Stores, the stores table will go into group by, which will generate an intermediate table. This intermediate table goes to this function here, summarize. Because of this pipelining, you don't have to mention the table names. So this statement here will give the same output as this statement, these two statements. So line 253 is equivalent to line 248 and 249. Clear? Any questions online, guys? Any questions online, guys? Okay. One last thing before we go. You all know the statements, right? Right? So R also gives you optional statements. Some of the samples I have written over here, some sample codes. You can please make it out, right? I don't have to explain anything. Please pay attention to this syntax here. On your screen, is there any question that you want to ask on this? This is pretty much self-explanatory, right? I'm going to take the drill machine and drill his head, man. Seriously. Yes. Now, moving on. More than an if statement, an if-else statement is more sensible in a language like R. If-else is the vectorized version of if statement. The problem with if statement is that it will take only one condition at a time. If you have to apply if conditions onto your vectors, you have to create a loop and do the stuff. But if you are using if-else statement, you don't have to do that. I'll give you a very small and a brief example of if-else. So the binning example that we had done, please look at it. I'll create a variable called food. So please look at the usage of if-else statement. If-else stores $location is equals to Kolkata. So the syntax of if-else is if-else, test condition, true statements and false statements. This is the syntax of if-else. If the condition is true, the statements written here in this argument will be executed. If false, the other part will be executed. So my logic here is, if location is Kolkata, then put it as, for example, sweets. If not, no sweets. No sweets, get lost. So if I run the statement at line number 4 and I print the contents of food vector, so wherever it is encountering Kolkata in this vector called stores location, it is printing sweets. If not, it's not a sweets. So this is a vectorized version of if-else. Had I been applying the same thing using the normal if condition, please look at it. If I use if stores $location Kolkata, then food is equals to sweets, else no sweets. If I use this, please look at it. It will throw an error. Warning. The condition is then greater than 1, only first element will be used. This is a non-vectorized version, so which will only work upon only one element. It will check for first element, it's not equal to Kolkata, and it's simply putting it as not sweets. It is not going to the next element at all. But an if-else statement will do that. So, moral of the story, if you are using any conditions on your data table, you have to go for if-else, not the normal if statement. If-else is a vectorized version of if-then else. Yes, Amit, if-else can be nested. So if I can just extend this example at line number 4 here, please pay attention. As a food here. So what was the street name? Okay. So if it is Kolkata, then put it as Sandesh. If not, what you have to do? You can specify in the else part, you can again specify an if-else statement. You have to be careful in the opening and closing brackets. Please follow the RStudio suggestion, whatever it is generating. So again in this if-else, I'll write one more condition here. So if else location is equal to Chennai, I'll just get this to next line here. So that's easier to look. So if it is Chennai, then it's Pongal. If not, what to do next? Use if-else again. So I'll do that in the next line. So if-else brackets stores $location is equals to Delhi Chole Bhature. Right, fine. I don't find it that interesting, but it's good, fine. Then if-else, oh, no offense again. It's good, tasty. Can eat it. Not an issue. Your life, your wish. Yeah. My life, my rules. You see that in teenagers' walls, right? So location is what we are left with, Mumbai. Then it's Vada Pav. This I'll say, this is disgusting actually. That's it. I'll run and now have food based on locations, right? What we had done in the beginning part. Any questions on this? The vectorized version of if else, right? Now, in R will try its best to avoid loops. R will try its level best to avoid loops. So it has given you a good set of functions called apply functions, which you can use it, and using apply functions, we can just avoid the necessity of using loops, right? So let's do one thing. Let's quickly create some user-defined functions. Okay, we'll do one thing. We'll just stop here. Let's not discuss user-defined functions in this class. We can do it fresh in the next weekend. That's more sensible and better. We'll stop it here. Now I'm not done with the class. Look, close your works classroom, guys. We'll see one last and small topic on our markdown, because there is nothing to teach. It's just to give you a push start on it so that you can you can take it to further level. Now, have you guys checked on the installation of R Markdown? Online guys, especially, you're sitting right in front of your systems. So R Markdown must be installed in your system. All you can do is go for install.packages as it is and install R Markdown. So if you can find this here, if you go for file, new file, R Markdown, this pop-up should come, which means every installation is successful. If not, go for install.packages R Markdown. It will download and install all the packages and all the dependency packages on R Markdown. Alright? Now once you're done with this, give some title. I'll say sample documents, author name and all. Now I have a small catch here. HTML is the default output for any system. To have Word running in your system, to have to get Word document outputs, it's mandatory that you should have Microsoft Office or OpenOffice installed. So you have to purchase Microsoft Office licenses or you have to download LibreOffice, which is free of cost, which is available free of cost. What is pirated version? I don't know. Like Microsoft Office is licensed, right? You have to pay for the license and stuff, isn't it?
Yeah. Right.
Yeah. Come on. So once I click on OK, I'll get this document here. This is in the format of .rmd for R Markdown. The .rmd file. So this file has certain features to go with, which will give you a very good documented outputs. If I just happen to show an output, just translate this to a user readable output. If I just do that, I'll explain you the process, but first let me do it. Look at the output here. So this is your document, or maybe if you can just export this to Word. I'll explain you the process in a wee while, but first let's see the output and then understand what we are doing here. So what I'm doing here is, whatever code I'm writing, I'm just trying to report it to the end user. Or like, let's say I'm creating a report for my client using this. So I'm running a summary statement, for example, for a cars dataset. I'm getting the file number summary output over here. Clear with this? And look at the way how it has presented. It has presented in a very beautiful way, right? Yes, it did. And now I had written some code for generating a plot. It is generating a scatter plot between two objects, right? So let's understand each and every component over there. First, I'll begin with text. So what I'll do is, to the sample file, I'll delete all the components so that it will be easier for us to understand. Okay. So it all begins with this. You are not supposed to delete this part. Of course, you can delete these three elements here, but don't delete this part, what you're seeing on the screen. Three lines, now these three hyphens are not random, but they are the part of the syntax. They are the part of your metadata syntax. So this three hyphens are highly mandatory. They represent a section or a title. So if I happen to knit it, there will be blank section or blank section title, right? So I can't delete that, the part which you're seeing on the screen. That's first thing. Second, any text you write on the blank side will be treated as a part of your output. So I'll just write a statement. This is a sample text. I'm writing the statement and saving it. This is treated as a part of your output. Please look at it. This is a sample text, right? Now, text can be modified in the following ways. You might be knowing the HTML heading tags, right? Standard HTML heading tags. So you have this, right? H1 till H6. So H1 till H6 is represented by a pound character, where a single pound, now I'll just write it like this, you can understand. The single pound is H1, 2 pounds H2, H3 and so on. H1 being the largest font. So please look at the RMD document here. I'll just, before writing this, I'll put up this. I'll say this is heading 1 and I have used a pound character here. Remember, pound character inside of a .rmd file here. This is a .r file. Untitled2 is a .r file where a pound character means a comment. But in an RMD, a pound character is a heading, H1. A single pound is H1. So if I save and knit it, what did I do? So here we go. This is heading 1, right? This is what it is showing over there. Any questions so far? So this is a sample text. So if I had used 2 pounds, this means heading 2. Net. This is heading 2. You can see that, right? Now, yeah. Now please look at this. Use double underscores. So like this. So this is a bold text, for example. I'll just enclose that with double underscore. keep doing this in WhatsApp, right? You have bold and italics in WhatsApp. This is how it is done. So if I knit it, so you see this is a bold text over here, right? Any questions? And I have here if anything is enclosed within stars, italic, right? So you got this in italics. So what is bold italics then? Underscore star. Okay. Underscore star. This is bold italics star underscore. That's it. Clear? And moving on with text, headers is done. I have list of items here. I just copy this to this. So a list should begin with star. So list of items. So if I do 4 pounds here, this is H4, header H4. These are the list of items that I'm saying, that's a text. If I put a star and say item 1, so again star, item 2. See, if I save it and I knit it, it creates an unordered list, right? And to create an ordered list, simply I can use numbers, items in order. Lol. Right? Right? Just put an enter key. That should do. Get into the next line, I guess. Yes, it did. Okay. And what else? Okay. To add sub items, it's just nothing. Come to the next line. Press one tab. Put a plus sign. Sub item for item 2. And this is again plus. I'll say sub item for item 2. Sub item 2 for item 2. And sub item 1 for item 2. First one. That's it. I knit it. Okay, I think I need one more tab. Clear with this? And for a ordered list, same logic, double taps, plus, right? Good luck doing your, you might have already done it. The laptops, right? So apparently it should come to the next lines. I think that should make more sense now. So if I knit, here we go, right? But it has to be in an ordered list. I don't know why it's not coming in an ordered list. So let's try what R has given us. I think I'm following the same syntax what R has given me. Okay, apparently I can't get it unless I name it that way. So I'll call it as 1.1. We'll call this as 1.2. I think this is better instead of using the simple plus sign. I think this is a better way of representing it, right? And about texts, I think you can just keep exploring the other options. What we have to cover now is how to write code chunks inside of our markdown. So to insert a code chunk, say below the code chunks. So this, is this a comment or is this a heading? So that's a heading in our markdown, right? To insert code chunks, I have to use the 3 apostrophes. It should begin with 3 apostrophes, the key on the left of your numeric 1. It's not the single quote. Please make sure that you're not using this single quote. You're using the apostrophes. And then followed by open and close curly brace. Now, our markdown speciality is that it can run our Python, C, C++ codes. So code chunk can be from any language. In this case, let us fix to our language, right? And immediately come to the next line, maybe next 2 lines, and close the 3 apostrophes. Now, if you look at it, this forms the code chunk. Is there any questions here, online guys? I hope you are following the entire process, what we are doing. 3 apostrophes, open close brackets, R, and close with 3 apostrophes. Now within this I can write a code and execute. So first things first, what I'll do is here I'll import stores dataset read.csv. Datasets. Yes. Next step, what I'll do is I'll say str stores. Here, str stores. And also I'll say summary stores. So I'll do that in next line. This is the summary of stores. How to do it? 3 apostrophes, R, and then summary stores, and then close with 3 apostrophes. That's it, right? I'll save it and I'll click on knit. So look at this now. Any doubts in this? It is not only displaying the statement, but also it is displaying the output generated from that statement. First line here is not generating any output, it is just creating an object, but summary stores str function and the below summary function is generating some outputs, right? That's why we have those outputs as well on the screen. Any questions? Online guys, any questions? I hope Ayush is the only person who is listening to this class. Yes. Okay. Now moving further, now I have certain options for this code chunks as well. Now, if you need only statement and no output, if you need to print only the statements not executed, so in that case use the option eval is equals to false. If you need only the statement and no output, use the option eval is equals to false. But still you have to write the codes. Without writing the codes it will not happen, right? Of course. R is now followed by an option called eval, which is true or false. I'll set it to false. R eval is equals to false. This is the option that I'm setting within the round brackets, within the curly braces. And within this, now I'll write a code which needs just to be displayed, not printing the results. So let's say require describe stores. Now if I'm knitting this, look at it. So only the statements are being printed, output is not being printed, right? Any questions? So I think it's all crystal clear. Now, next up, of course, you will be guessing what will be the flow next. And that's if we need only output and no statement. In that case, use the option echo is equals to false. Instead of eval, use the option echo. So if I say echo is equals to false, so what I'll quickly do is I'll just copy the group by code here, group by summarize code. So I'll put it in sample R&D here and say print result table 2. Right? So if I'm executing this, if I'm knitting this, because this is a different session altogether, I have to load all the packages. See over here, only the output is being printed. So whatever you would be seeing in the console, that would be printed over here. Right? So that's with that. And finally, if you don't want anything, I think I have an option called include. Yes. So if you don't need any output or statements, so let's say more of like if you don't need both output and statements, use include is equals to false. So let's say you're loading packages in one go, or you're just importing tables which you don't want others to see it. So use a chunk which says include is equals to false. So let's do one more thing here. Let's say sort or arrange stores location, for example. So if I say include is equals to false, that doesn't get included in the entire document. See, the code doesn't come over here. The code chunk is neither executed, nor it is executed. It is being executed, but it is not being displayed. The statements and the results are not being displayed. Right? Now, what you will do is, this is the fourth task of your day for your next week, is that you have to go through this document here called R Markdown cheat sheet. To go through this cheat sheet. They're not cheat codes, but it's almost like the slips that people carry to your BTech exams. The BTech guys know that. We did it. We did a lot of it. Other branches, like we used to think, like what miserable life these people would be having. We used to take these chits and stuff, right?
But we will be able to use that cheat code in only theoretical class, not in the
Which practical? The lab exams?
Yeah.
Come on, you can have a set of observations as a cheat code, right?
Yeah, of course.
You do a p-n junction diode, get all those observations done, and just match it for namesake. Just match some values, draw a graph, say that this has done. If that is not coming, you're not being able to show it to your engineer. Just tell them that faulty equipments and stuff. Yeah, do that. Dude, BTech man, we enjoyed a lot. That's why we are here now. sad story of our life, man, seriously. So yes, please go through this cheat sheet of R Markdown, and you can just try out your options. And believe me, R Markdown is not as good as your ODS. ODS is one of the best things ever to happen in this world. But R Markdown is sincerely trying to match a production level outputs using this. There are a lot of things that can be done using R Markdown. Things are not simple as drag and drop. No, you have to put efforts, but whatever things we are discussing in the class, for example, this file here, 15th April.r, which I had given you for your yesterday's class, this entire thing can be represented in a very well-mannered way using R Markdown. You might have also got some materials, right? Some PDFs. Those PDFs are generated using R Markdown. Except that we use Word, and we added those headers and footers in Word. That's a different story altogether. That's called a little bit cheating, but these all are done using R Markdown. I want you to be thorough in that R Markdown, because Shiny is something which we can't teach you, but at least we can teach you R Markdown statement. We are not done with R Markdown yet. I want you to do the assignments, the first assignment of R that you're getting. I want you to give it a shot and submit it in R Markdown. You can submit the .r file, it's not an issue, but you can just go that one step ahead, be proactive, and do the assignment in R Markdown. It will be much better for you, good practice for you on that technology. Yes, I sincerely hope you would be trying it, right? Okay. I couldn't hear you. Would you be trying? Okay, that's fine. Sahil, yes. I can export it to HTML. I can export it to Word. If I have the software LaTeX installed in my system, I can export it to PDF. And no, I can't export it to an Excel sheet. It cannot export it to an Excel sheet. Clear with this? All right.